Hey guys, welcome to my channel and topic for today is Leetcode number 153, find minimum in rotated sorted array. So this is video number 8 of binary search playlist. For the previous content you can watch my playlist. So let's just read the question first. So what the question is saying is, suppose we have an array of length n and it is sorted in ascending order and it is rotated between 1 and n times. Okay, so the array might be rotated at 1 times or n times. For example, the array of nums 0, 1, 2, 4, 5, 6, 7 might become this or it might become this. If it is rotated at 4 times, it will become this. If it is rotated 7 times, it will become this. So the original array. Okay, so basically what we want to find is, we given this array, we want to find the least element. Okay, the array might be rotated, so 4, 5, 6, 7, 8, then 1, 2, 3. Then we want to find out the lowest element in that array, so that is, in that this case it is 1. Okay, so 0 is the lowest in this example, so we are returning that. In this example it is 11, so we are returning that. So let's say we have this question, and let's understand this question using 3 examples. Okay, so for example number 1, I have 0, 2, 4, 6, 8. Okay, and the indexes are 0, 1, 2, 3, and 4. So as you can see, if you draw the graph, this will look something like, in this, the array is always in increasing order, right? So we can check if the array of s is less than array of e. Okay, so we can say this as the starting index, this as the ending index, and we can ask a simple condition. Okay, if array of s is less than equal to array of e, that means the array is already sorted, and we know in the sorted array the least the least answer that we can find is on the left side. Okay, so I can return array of s as the answer when the array is already sorted. So let's take a look at second example. So in the second example, what we can say is, we have array 6, 8, 1, 2, and 3, and if we calculate the mid for s and e, it will always be at the second index. Okay, so given that knowledge, what we can say is, uh, if the array is sorted, if the array is sorted, will always have the answer at the leftmost index. That is what we saw previously. But if it is rotated, okay, if the array is rotated, that array will always follow this structure. So there will be a peak, then there will be a valley, and then there will be a peak. Okay, in that case, what we can say is, we can see the relation between thus s, and we can see the relation between s, and we can see the relation between mid. Okay, so let's calculate mid, s plus e by 2, and we can ask a simple question: is array of s greater than array of mid? Okay, if this is true, if the array of s is greater than array of mid, okay, that means we have found the peak. Okay, then that means there is a peak and then there is a valley. Okay, then there is a peak and then there is a valley. In that case, what we can say is, we already found the lowest point, and the right side, this right side can never be the answer. Okay, let me explain again. So if I say 6 is greater than 1, okay, that means the answer we are looking for is 1. Okay, then wherever there is a valley, wherever there is a peak at up, okay, or wherever there is the peak at right, it doesn't matter, since we already found the valley. Okay, we found the valley. Okay, the relation between s and mid was decreasing. Okay, the relation between s and mid was decreasing. So even if there is a peak at this point or there is a peak at this point, it doesn't matter. Okay, so we can exclude this part, we can exclude the right of the mid, since we are not going to find the answer after that. Okay, since the if the array is rotated, there will always be one valley. Okay, and that one valley we have found. Okay, so in this case, if we found if the array of s is greater than array of mid, okay, that means the right side can never be the answer. So we can exclude the right side of the mid and we can place the end pointer to the mid. Okay, end is equal to mid. Otherwise, if that is false, we will do something. Okay, so let's take another example now. Okay, so let's say the array was 5 6 8 1 2 and the mid was pointing, the mid here is right here. Okay, mid is actually on the second index. Okay, so in this case what will happen is the relation between s and mid is not decreasing but actually increasing. Okay, that means if the array is rotated, the this whole the first peak is always higher than the second peak. Okay, so the answer must lie on the right side, answer must lie on the second peak. Okay, the starting point of the second peak. So we can surely say that if the relation between s and mid is going up, okay, then this whole thing we can eliminate since the answer is not going to exist on the first peak. Okay, so we can say that s will move to mid plus 1. Let's just do dry run on the same example to understand it better. Let's calculate mid. So the starting index is this, ending index is this. Let's calculate mid. S plus e by 2. Mid is going to be 2. This is where the mid is going to point. So why is it 2? Because it is 0 plus 4 by 2. It is going to be 2. Okay, once we have mid, so before calculating mid, we need to check if the array of s is less than equal to array of e. What is my array of s? My array of s is 5. Is 5 less than or equal to, is 5 less than or equal to 4? The answer is no. Okay, so that is the reason this won't be executed. Then we'll find mid. So that is what we did. And after that, we are going to check the relation between array of s and mid. Okay, so what is my array of mid? So this is where the mid is pointing. Okay, at what value is it pointing? 8. Okay, so let me write the values. This is 5 6, this is 8, then we have 1, and then we have 2. Okay, so mid is currently at 8. So we are going to check if array of s is greater than array of mid. What is my array of s? Is 5 greater than 8? The answer is no. Okay, so this won't be executed. It will go to the else block. So right side can never the first peak can never be my answer. So I'm going to take the starting index and move to mid plus 1. This is where the mid was pointing. This is where the mid plus 1 will be. So s will go around here and the whole left side will be excluded. If 1 is less than equal to 2, that means we found the answer. We should have returned 1. Okay, is 1 less than equal to 2? Yes, then we can return 1 as the answer. Okay, so let's say we have array 6 8 1 2 and 3. Okay, and we have represented this graph of that same array, and we have the code on right side. So the first thing we have to do is s less than equal to e? Yes, it is, since s is 0 and e is 4. So this is valid. Next is we are going to check if array of s is less than equal to array of e. That means, is my array of s less and is my array of e more? So we are actually checking, is the array already sorted? So the array is not sorted, so it is going, we need to calculate mid. So what is my mid? Mid is going to be s plus e by 2. So we can say that mid is equal to s is 0, E is 4 by 2. The answer is 2. So we have found mid. So what is my mid? My mid is going to point at the second index. This is where the mid is. Now the next step is to check the relation between array of S and array of mid. So what is my array of S? My array of S is 6. Is 6 greater than, what is my array of mid? 2. Okay. What is my array of mid? Array of mid is going to be 1. Okay, so that is what we're checking. Is 6 greater than 1? Okay, the answer is yes, 6 is greater than 1. So we do not need the right side of this. Okay, right side of the mid. So we can exclude the right side. Okay, so if 6 is greater than mid, then we can exclude the right side. Let me exclude the right side. And we can place the end pointer right here. So this is where the E will point at. Okay, so we will do the second iteration now. We are again going to check the same thing. Is my array of S less than equal to E? Is the array sorted now? Okay, so we have 6, then we have 8, then we have 1. Okay, so 6, 8 and 1. Are they sorted? The answer is no. Okay, so we will again find out the mid. S is equal to S, mid is equal to S plus E by 2. What is my mid going to be? Let's calculate. Mid is equal to S plus E by 2. Mid is going to be 0 plus 2 by 2. It is going to be 1. So this is where the mid is going to point. So this is where the mid is going to point at. Okay, so we are going to ask relation between mid and S. Is array of S greater than array of mid? Okay, right now S is 6 and array of mid is 8. Okay, is 6 greater than 8? The answer is no. Okay, 6 is not greater than 8. So we can say that answer can never lie on this side. Okay, and we can take the S pointer and move to mid plus 1. Okay, so where is my mid? Mid is mid. This is my actual mid. So let me erase the previous mid. Okay, so we can take the S pointer and move to mid plus 1. So let me exclude the whole thing. Let me move the S index to mid plus 1. This is where the mid was pointing at index number 1. Now the mid will point at, the S will point at mid plus 1. So let me write S right here. Okay, so now we will again ask the simple condition. Is my array of S less than equal to array of E? Yes, the array of S right now is 1. Is 1 less than equal to 1? The answer is yes. In that case, that is going to be the answer, and we are going to return array of S as the final answer. So let's start. I have int S is equal to 0 and int E is equal to n minus 1. So what is my n? N is equal to array, that is nums dot size. Okay, so I have set the starting and ending pointer. Then I'm going to go while S is less than equal to E. Okay, I'm going to check if array of S is less than equal to array of E. If that is true, the array is already sorted, then I'm going to return array of S as the answer. Otherwise, I'm going to calculate mid by the safe way. S mid is equal to S plus E minus S by 2. Okay, then I'm going to ask a simple condition. Is array of S greater than array of mid? If that is true, then I'm going to say that E is equal to mid. Otherwise, I'm going to say S is equal to mid plus 1. Okay, if we had answer, we'll already find at this point. Otherwise, we will return minus 1. So let's just run the code. So it is giving you an error. So yeah, array is not defined. Nums, 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 and nums. So let's just run this out. Yeah, so it passes all the test cases. Let's just submit. So yeah, that's it for the video. If you like, kindly subscribe. Bye.